I want to talk about this problem. We're talking about linear regression, making lines a best fit. So, beer and blood alcohol content. Many people believe that gender, weight, drinking habits, and other factors are much more important in predicting blood alcohol content than simply considering the number of drinks a person consumed. Here we example data from 16 student volunteers at Ohio State University who each drank a randomly assigned number of cans of beer. These students were evenly divided between men and women, and they differed in weight and drinking habits. 30 minutes later, a police officer measured their blood alcohol content in grams per alcohol per deciliter of blood. The scatter plot and the regression table summarize the findings, right? So here's our scatter plot, right? The more cans of beer you drink, it looks like, the higher your blood alcohol content goes, right? Here is a regression table. This looks different than the table that we would use because we're just using our Google Sheets calculator, but this still tells us basically the same information. Um, if we were to make a line through these points, right, we'd want to know the equation of that line. And the equation of that line is always going to look like y is equal to mx plus b. Let me keep track of my equations here. So anyway, if I can bring your attention over here, we want the equation of a line, our regression line, to be in the form y is equal to mx plus b. Um, yeah, where y represents the same units that are on the y-axis. In this case, it's blood alcohol content, and x represents the cans of beer you've had, right? So we want to make an equation that would do that for us. M is, of course, the blood alcohol content over cans of beer, right? And so to make this equation, I'm just going to type in y equals m. We got to figure out what m is. Well, it tells us here, actually, right? This is our m value. At least this calls it the estimate for the m value. So let's go ahead and type this in. 0.0180. And then our intercept is also given to us. It is negative 0.0127. Right? So every time we have one more beer, right, this value will go up. Our blood alcohol content will go up by a little bit. It tells us our t value, which is great. It also tells us the probability right here. And it tells us the probability too. So let's see, we go down to this thing. It's written backwards in the way I wrote it, but notice this one's multiplied by x. So what would this be? This would be like 0.0180. And then this one would be negative 0.0127, right? That would be our intercept. And then you have the interpretation of the slope for each additional can of beer. The blood alcohol content expect to increase by this amount. So that's what's happening in our slope. Yeah, the p-value for this test. Well, let's scroll back up here and find our p-value for this test. Right? The p-value for this test, it looks like it is going to be, sorry, we should read the test first. The number of cans, so here, do the data provide strong evidence that drinking more cans of beer is associated with increased blood alcohol? So we would assume that our null hypothesis is that no, right? It doesn't do that. The number of cans of beer drank is not a significant predictor of blood alcohol content. And then the alternative hypothesis is what we're going to show. The number of cans of beer drank is a significant predictor of blood alcohol content. So we go back up. What do we do? We go back up and we say our p-value. The p-value for the number of beers drank is this value, 0.00. So I'm going to type that in. I probably don't need that many zeros, just 0. And then our correlation coefficient, right, is r squared. And we can go back up to here to find our correlation coefficient. Oh no, we can't. Oh, here it is. The correlation coefficient for number of cans of beer is 0.89, right? You want to calculate r squared. Is it not that? I want to, what? Let's see. Calculator. Let's just do 0.89 times 0.89, and we get, oh, no, I get 0.7921. So that's what that should be, right? 0.7921. Cool. And that should be it. That's it for getting those computations there, right? Yeah. If you have any questions, let me know. Okay.